Okay, hi, I'm Mark Mccahill. I'm a system architect at Duke. Um, this is going to be fairly casual, and I know most of you, probably all of you, don't run infrastructure like I do, but I think this is still useful information because you as instructors, as people who run courses, can do things to make my life easy or extremely hard. And we've been running this stuff at Duke for a long time. So I think we've made pretty much all the mistakes that could be made. So I can tell you as an instructor, here's what to do or what not to do. And if you're an infrastructure person, I'll also say, here's how we're putting things together. Okay, so we cool? That good? Great. So 10 years of running RStudio. Mine Sitinkaya Rundell came to me in 2014 and said unto me, hey, we've got a problem. We need to run RStudio, but it's kind of a pain the way we're doing it right now. Isn't there a better way? She told me her woes, and I said, I think we could do this a better way. I think I want to use Docker containers for this. I haven't done this before for a course, so it's going to be an experiment. Somebody's got to go first, and it's you. And Mine kind of went, okay. And I think Colin was there too, and Colin went, well, let's try it and see what happens. It worked out, although we made a few mistakes along the way. So the mistakes I made, I did better, or tried to do better each time, like the cat here. And so I'm going to tell you things that we found the hard way so that you don't do that, okay? I'm going to tell you what I screwed up so you don't do that. I'm doing you a favor here. Yeah, we learn by making mistakes. Don't stick your head in the jar, really. Okay, motivation. Why are we doing Docker containers for RStudio and running massive RStudio farms for students? Motivation. If you want students to run RStudio, it's going to have to happen someplace. The students instinctively would like to run it on their laptop. They just feel like, well, of course, I put it on the laptop that I bought to bring to the university. That's what I should do. And at some point, they really need to learn how to do that, but maybe not in intro stats. Maybe you've got other things that are more important to cover than debugging how they didn't install it quite right this time, or got the wrong library this time, or screwed something else up. That takes time. If you want to factor that out of the course, then you want to standardize everything. You want a common experience. And you can get that if you're running RStudio on servers that they access via the web, right? So now they've got the same hardware. Everybody's got the same environment for compute. Same packages are installed. Same data sets are there. If you put data sets up there, you've taken one variable out of the mix. That's nice. Now you can focus on what you're trying to do, which is teach statistics, not teach installs of packages on laptops that are all over the map. So that's a big motivation for doing this stuff. Another motivation is if you're using some external cloud-based service for this, maybe the students aren't using their campus net IDs to log into that. Maybe you're going to have to map between what their campus identity is and what they're using to log in. At least that was a problem 10 years ago. That was something we wanted to get away from. So another gotta have here was the students use the same ID that they use everywhere else to log in. Kind of important to do that. So, solution that we proposed and we've been using a lot at Duke is run RStudio for the students in a web browser. It's really good for large enrollment classes. That's great. Sounds like problem solved. This is the end of my talk. Well, maybe not. Maybe there's still issues. Once you sign up for this, now you signed up for the RStudio web server, or servers are a shared resource. Now students are competing for compute cycles on that shared resource. This brings with it some issues. Another issue is instructors want control of the packages and data sets. They don't want to come to me every time they decide, I'd really like to add this one package to the environment because I just realized that we need that for the next assignment. Making it so there's self-service updates by the instructors takes me out of the loop and gives the instructors control over what they're doing. Meaning the instructors can customize the R environment to what's specific to their course. Kind of key. I think you want that as an instructor. Another issue is that there's going to be variable demand. I'll tell you, running infrastructure, I can tell when the assignments are due, man. I can totally see that. What's nice is if the assignments aren't all due for all the courses at the same time, we can kind of multiplex multiple courses onto shared infrastructure and keep the bills under control. But there's variable demand and peak loads. That's something you got to deal with. So how do you size the infrastructure that runs the server? That's an interesting challenge for the infrastructure guys. But you, instructor people, you have a role to play in this too, which I'll get to. So what are we doing at Duke? I wrote an application called Container Manager that is a place where students can get to their course-specific personal instance of RStudio, right? Each person gets their own personal instance of RStudio specific to that course. If they're taking 3 stats courses, they'll get 3 different containers for each, one for each of the courses. Great, because the courses have different environments, works fine. We're using Docker, which I'm not, if anyone knows what Docker is, raise your hand. Oh my God, it's great. People do know what it is, finally. So, standardized way of packaging up application and libraries, portable, scalable, all that. It's the way to roll. So basically, Container Manager is students log into the reservation page, which is a web page, and Container Manager says, oh, you're Mark Mccahill, I'm going to assign you this container for this course. I'm going to have a persistent directory, home directory for you so your work sticks around. And when you come back, you're going to get the same one each time. So it's really Container Manager, just a reservation system. What's it look like? Well, you log in and you get a list of things you've got reservations for. We started with RStudio and ended up doing it for almost all of the undergrad courses that do computational stuff. So we run Jupyter Lab, we run a bunch of computer science stuff here, Maple, all sorts of stuff. So it started with RStudio and turned into general purpose containerized environments for coursework. When you click on the statistics 198, 199 button, you get to a page that has a login. Guess what that does? It logs you in. Another thing that I'm going to mention now, getting ahead of myself, there is a restart request. Students could say, oh, it's not working. Maybe I should try restarting it. That's useful because sometimes students get themselves wedged and they can unwedge themselves without talking to me by just restarting the container. So if you're doing this stuff, you really want to give them a self-rescue option, restart your container. A lot of times that fixes it and you don't have to talk to me. And once you click on the login and start, there you go, it's R. Behind the scenes, the ugly truth. What's going on back behind this? The student, the little blue ball, clicks and has a login. At Duke, we're using Shibboleth for that. That sends them into the blue box, the reservation system, which says, okay, look up where the student goes. Let's redirect them and send them over to the right container. We're doing a bunch of servers, the purple boxes, with Nginx, HTTP proxy that also can do some authentication, and the student instances. I'm running Nginx and calling it out here because for doing RStudio this way, we have to run RStudio as no login enabled on the actual RStudio itself. So we're using Nginx to say only this student can get to that RStudio. We're doing this because I don't want to do the enterprise flavor of RStudio because I want these containers to be able to run, if necessary, on somebody's laptop or elsewhere, okay? So I'd love to do the enterprise version, doesn't fit for what I'm trying to do, so I have to play a little game with Nginx. If your infrastructure people want to know how that works, have them talk to me, I can explain it and show them the code. A key part of this addresses the issue of the instructor wants to be able to control their environment. So sitting on the side in green is a GitLab repository, a Git repository. We script the builds of the containers. They're run from a repository so we can update them. The instructor can do an update to that script. Colin Rundell is notorious for doing updates to that script. all the time. When he does that, a new version goes into the repo. We've got two branches, a test branch and a production branch. If you push into test, it will attempt to build the container and put a new instance out running on the infrastructure so you can make sure that it works. Test before deploying to production. If it does work, push the same stuff to the main branch, and then the continuous integration automation will build the container and redeploy it to all the students. This means when somebody decides at 12:30 a.m. while I'm asleep that tomorrow's lecture would benefit greatly from having a package that's not in the library or in the image, they can go update, test, and deploy. I sleep soundly and they're happy. What happens if they screw it up? It's Git. Roll back to the version that worked. Deploy that. Okay? This lets you scale it and not run everything through me. So I'll do an initial setup of this stuff, and then I fling the keys over to the instructor and say, okay, you want changes? Knock yourself out, and roll back if you break anything. And it works reasonably well. Colin, does it work reasonably well? One thumb up. This is all in service of running student code. And this is what running student code is like. They're innocent, but something's on fire. Something bad is happening. But they think it's cool. So what could possibly go wrong? The stuff that I've learned the hard way. There's many failure modes, of course, that you would expect. Memory leaks. Students got something that eats all the memory. Then we're running on Linux. It's trying to swap for more RAM to disk, pounding the disk. That's not good. Tight loops. Student runs a loop that will never terminate. And the CPU just gets maxed out. And I can't even log into the server. All I can do is restart it if they really wedge it hard enough. Storage, IOPS, I/O per second, storage accesses. If there's a huge backlog of attempted writes or reads to disk, that can also bring the server to its knees. And the real death spiral is a memory leak eats all the RAM, which then starts swapping to disk really hard, which eats all the I/O capacity. So now the CPUs are backed up trying to get there, and the I/O is backed up. I'm running all of this in Microsoft Azure, a cloud service, and they have very hard limits on you exceed the max IOPS for this thing, that's it. Cut you off. So it is possible to run right up against the wall and max everything out so that good things aren't going to happen anymore. Another way this can happen isn't students. Web crawlers occasionally can bring you to your knees, but they're easier to deal with than the student stuff. What are the mitigations? This is all the bad stuff that might happen in the shared environment. By the way, it can happen on their laptop too, but they don't have anyone to help them on their laptop except maybe you. What are the mitigations? The short-term fix, if it's really wedged, is, well, restart the server or redeploy, right? What else can you do? I count it as a loss every time I have to do one of these, especially when there's a class going on, but you guys, you killed me. All I can do is a restart. Another mitigation is log everything so you can figure out who was involved in the problem, right? If there's a mystery problem occurring and you don't know who was trying to do things, you got no clues. So Container Manager logs every time someone goes over and starts up an RStudio session. This gives me a clue of who was doing something so I could say, what were you doing? What were you trying to do? Could you try that again so I can see if that's the problem? The real tool I've got to work with are C group limits. C groups are a Linux thing where you can say this process can do no more than this much I/O, or no more than this much RAM, or no more than this much CPU cycles. So I can make it so they can't consume everything on the machine. I can say you have this much and that's it for the container. That works great if I can figure out what the right place to set that is. If I set the limit too low, your assignment won't work, right? If you've got an assignment that's got a big data set and I set the limit really tiny, nothing good's going to happen. The assignment's not doable. So I want to have the limits set high, but not so high that if everyone's doing it at the same time, they can take the server to its knees. So what I beg instructors for, especially the first time we're running a course, is please, please, please give me a test case of the worst assignment, the toughest assignment you think there's going to be in terms of compute. So we can try running that and see where we need to set the limit so it can run, and then set the limit maybe 50% higher for some flailing around. If I can get that, at least I have the feeling that, well, I did my best, I tried. Right? I have said this to you. I say this all the time. Alas, the first time through, new instructors are somewhat reluctant to work with me on this, and so we just make a wild guess. Which brings us to a case study. Not naming names, and the guilty party's not in the room, so that gives you another clue. Intro Stats 2021, new instructor, all new assignments. Well, what was working before seemed like a good place to start, and I didn't get any new thing to try, so let's just roll with what we had set before. Well, what happened about 3 weeks in, I think second or third assignment, is intermittently in the evening when the students are trying to do the assignment, things would get backed up and nothing good's happening. Servers are on their knees. And all I can do is like a restart, which then throws everybody off. And a couple evenings I did a restart and it was okay for a while, and then the people who were creating the problem came back, problem again, restart again. Eventually they're dissuaded from trying again that evening and other people can get going. But this is not a good place to be. This is the cat with its head stuck in the jar with no clue of how to get out. Eventually, by looking at the logs, we were able to identify which students were active when we hit the IOPS limit. So, the students, they're just working on the assignment, but nothing good is happening. What else could go wrong? First class lecture, flash mobs, lots of people come in, hit the server hard, so I need to make the servers bigger. The way the courses are taught have moved towards more of a workshop style where everyone's working along with the instructor at the same time. That means I had to make the servers bigger. We just learned that the hard way. Occasionally it's the network. In big rooms, the network may not be able to keep up with the wireless demands if you're having all the students work along. Self-inflicted DDoS by mass downloads. You can kill other sites by having all your students download from an under-resourced site that has the data set in it. Stage it up. So, automation lets you do it at scale. Things will be tough for the first couple weeks. We run the courses on different servers, so one course doesn't mess up another course. The students are great at testing, and dynamically resizing is a win. Which brings me to running the same stuff over at NC Share. NC Share is a regional initiative that Duke's part of. So schools who are in North Carolina, if you're not part of NC Share, hi thee unto ncshare.org and get yourself involved. Because we're running the same kind of infrastructure that we run for Duke over there. And National Science Foundation funded this. And we just started getting some GPUs too. So it's a cool thing. Same model as before, except I swapped out the authentication to have a little shim that lets you use your campus authentication to get to the containers. Looks the same when you first log in. You have to pick your institution. Looks like the other slide, except a different color scheme. The regional collaboration thing has been a big win for the smaller schools in North Carolina because they can take advantage of the stuff that we're doing at Duke to start with for the containers and the infrastructure, and we've got testimonials from Davidson College that this is a good thing. So, it was easy to port what we're doing over to NC Share. NC Share should be intriguing because it just got a load of H200 GPUs, which are hard to come by and really powerful. And that takes me to the end of my talk, roughly on time, right?